In continuation with the previous 4 videos, this is the last video of the data mining where we will be discussing the module 5 super important questions. So basically what you need to focus upon here is the clustering. Okay, clustering means what? You have a large group, you will be dividing into different sections here, and each of these sections is called as a cluster. And how is the division made? Is not the random division. The division is made on based on the similarities and what dissimilarities. Based on what is similar, that will be in a single group, and based on what is dissimilar, that will be in separate groups. Okay, so more the similar things, the more close it will be in a single group. Like that we will be discussing the techniques which you can use to form the clusters. Okay, first you need to know what the definition of the cluster and the different types of clusters. So there is a definition, what is the cluster, that you need to know. After that they can ask you different types of clusters. So the different types of cluster is also there. Also they can ask you different type of clustering. Okay, don't get confused, many people get confused between these two. Different type of cluster is a separate question, different types of clustering is a separate question. Okay, so these three questions can be found in the first topic. And then we have some algorithms like k means algorithm. Okay, so what does k means? You will be having k values here. Based on the k values you will be assigning the different data sets to these three values. Okay, like you will be finding the mean, again you will be doing iteratively until no change is made. So we will discuss this in brief in this video, and we will discuss in depth in a separate video, because algorithms and all I will discuss in a separate video, as well as the numericals are asked from this topic. Okay, so let's discuss that in a separate video. And after that you have another algorithm, which is agglomerative hierarchical clustering algorithm. In agglomerative and hierarchical there is a difference that you need to know, what is the definition and the difference. Okay, after that there are some proximity terms like the min, max and average with suitable diagram and the limitations. All the algorithms have some strengths and weakness that you just need to keep in mind, just one word. Okay, what I mean is, if suppose that strength and weakness topic starts from here, it will be like this. Okay, what you need to know is key points are there, right? Just one word: efficient, time consuming, storage, expensive, redundant. That much only you need to know. Don't read all of this. Okay, time is very less, so just read these words here and keep these words in mind. And let me tell you, all the algorithms which have the limitations and the strengths, all of them have similar limitations and strengths. Okay, so just keep in mind some words for the strengths and some words for the limitations. No matter what algorithm they ask, you are supposed to write that only. Okay, the same limitation and same weakness, let it be right or wrong, write that only. Okay, because it's very hard to keep in mind all the separate algorithms strength and weakness separately, and time is also very less. Okay, so after that you have DBSCAN algorithm, density based scan. Then we will be discussing the cluster evaluation. There are three approaches of it, and we have the density based clustering algorithms. Three are the grid based, CLIQUE and DENCLUE. Then we have the graph based. Here there are 8 algorithms, and this is not even asked in the previous paper, so I am not covering this one in the this video, but this covered in the theory video. If you want, you can go through it. And scalable clustering algorithm, there are another two, which is CURE and BIRCH. Okay, so we'll be discussing all of this in this video. And if you like this video, hit the like button, and don't forget to subscribe to my channel. Your support helps me make more videos like this. Okay, so let's get started with the first question, which is definition and different types of clusters. Okay, so this PDF you can find in the link in the description box, where it is written 6M PDFs. There is a link in that super important. Okay, so in super important you can go and you can find this one. And the notes which I am referring, in the same link, 6M link, you can find a folder called as 18CS641, the subject code. Okay, in that you can find the notes. In that all the 5 module notes are there in a single file, so you have to refer that only. First, what is the definition of cluster? Okay, what do you mean by cluster? Clusters definition is: cluster analysis groups the data object based on the information found in the data. Based on similarities and dissimilarities, it groups the data into different partitions or the different groups. That is known as cluster. Each of this is called cluster. Write it in your own words. The main set is there. The main set is divided into different parts based on the similarities and the dissimilarities, and each of these form a cluster. And this technique is called as clustering. Like write like this only. Okay, and if they ask you to give the example, you can give the example of any of the means. Take the example of university students. Many students are there, and how the clusters are formed based on different branches. How the clusters can be formed based on different semesters. Like that, based on what is similar between them and what is dissimilar between them, you are grouping them into different parts. That is what is the clustering. Just if you keep this in mind, your first key point is over, the definition of clustering. Then they have asked two things: the different types of clusters and the different types of clustering. Different type of cluster and different types of clustering. So if you they ask you about different types of clustering, you have to mention 4 things: Hierarchical versus partitional. Hierarchical means what? You will be having the data present here. See, here is the example. It is a set of nested clusters that are organized as a tree. Okay. So, in the way of the tree, you will be partitioning, like if this is the main subset, you will be partitioning based on like this. Okay, this is known as hierarchical. There is a hierarchy present in it, that is hierarchical partitioning. And partitional clustering is you will be having different partitions, and based on the similarities and dissimilarities, you will be further classifying them into different clusters. So, here you are forming what? Partitions. In hierarchical, what you are forming? The different divisions, simply a division of set of data. Okay. Then we have the exclusive, overlapping versus fuzzy. Exclusive means the data set belongs to only one class. The data set belongs to what? Only one class. The different data sets is there, it exclusively belongs to one class only. That is called as exclusive. What is overlapping? The data does not belong to a single class, but some of them belong to the two or more classes. That is called as overlapping. Fuzzy means the data will be belonging to 0 and 1, that much only you write. What is the fuzzy means? It will be belonging to 0 to 1. Whether it makes sense or not, just write 0 to 1, that should be sufficient for you. Okay. Then you have the complete versus partial. Complete means if this is my data set, all the data points which are present here, that should be belonging to our class, not a class, it can belong to multiple class, but the main thing is all the points should belong to something. Partial means some of these can be left out. It is not compulsory that all should belong, some can be left out. That is the difference between complete and partial. If they ask about different types of clustering, what you will write? First one, hierarchical versus partitional. The second one, you will write exclusive versus overlappy versus fuzzy. Third one is complete versus partial. These three things you have to write. If they ask you about different types of clusters, at that time what you have to write is well separated cluster, means they have a well separation in between them and there is a space between them, and this is densely classified. That is the first one, well separated. Second one is prototype based or the center based. Center based means there will be a center present here, and which is close to the center, that will be assigned to that cluster. That is known as prototype based or center based on similarities. Graph based means the graphs will be there, like how the connection is made between the two clusters. Mainly keep in mind, for the graph, connection is made between these two. That is only called graph based clustering algorithm. Then we have density based, based on density, how dense they are, the clustering is made. And shared property means some of them overlap, like if this is one graph made, this is also another graph made, overlapping is happening in between, that is called as shared property cluster. Okay. So, these are the different clusters what you have to mention if they ask about different types of clusters. I hope so that is clear. Let us go on to the next one, which is explain k-means, very important one. K-means algorithm. Write the algorithm, explain the working procedure with a suitable diagram and example, mention the limitations. Okay. So, let us see what is the meaning of k-means. K-means means you will have k things. Okay, you will have k things and there will be n objects. How many objects will be there? N objects will be there and there will be k things. K things means k points. Suppose that you have 10 objects. Okay, let us take 10 objects. Okay, and you have 2 points. Okay, k is equal to 2 means 2 points will be there. Now what you are seeing, if this is 10 and this is 20. Okay, now what you are seeing, what are the numeric values of each of these? Suppose that this is 1, this is 2, this is 31, this is 40, like that it is there. Okay, and so on. Now 1 and 2 are closer to which one? 10 or 20? It is closer to 10, so you will mark it here. 31 and 40 are closer to which one? 10 or 20? You will mark it to here, it is closer to 20. So in this way you are finding out the points which are closer to the given points, the given k points, and then you are assigning the data points. That is what is called the k-means clustering algorithm. After you have assigned these points, you have to again calculate this value and this value. Again you have to calculate what? This value and this value. How will you calculate these both values? You will just add up these points given here and divide by the number of points. Means you are just calculating the average or the means. Okay. After you have got the mean value, then you will be again assigning that as this one. Again what you will do, you will get 2 new mean values for the given points here and here, and then again you will be calculating the which are the points closer to the new mean value. Again some points will get included, some points will be excluded. Again you will calculate the mean, again you will do the same thing. Till when you will do, till that time you have to do until there is no change in that. Means if you assign some points, calculate the mean, again assign some points, calculate the mean, and there was no change in the previous assigning and this assigning. That means the algorithm has stabilized or normalized, and there will be no more further changes happening. That is when you will stop the k-means algorithm. If you can explain this much, you will easily get full marks. Okay. So let us see what is the algorithm, like briefly algorithm, and then we will be going to the next question, because in depth I will explain in a separate video, as well as there is a numerical. Okay. So here some formulas are there and the numerical is also there. So there is the numerical, I will be explaining in a separate video. So for now I will just explain what is the brief overview of this algorithm. Okay. So let's go to directly algorithm. The theory part of what I explained, you have to write this much. At least make sure it is till half page. Okay. After that, start the algorithm. Don't directly start the algorithm. If you forget some key points, it's compulsory that you have to write the theory as well. So first start with the theory, then write the algorithm. Okay. So see what you will do. You will select k points as the initial centroids, then repeat. You will select k points continuously, and then you will form k clusters. Then recompute the centroid. Centroid means what? The mean value. Okay. Again you will calculate the mean value, and again you will do until centroids do not change. That's all. That's all k means is algorithm is. Easily you can get 10 marks. Okay. That's all what you have to write. If they ask you about the diagram, you have to write this diagram. You can write this diagram. In the first iteration what's happening, in second iteration some get merged, in third iteration another merge, and there is a very large space in between, so no more changes will be found. In the iteration 3 the algorithm is stabilized, so there you will stop it. Okay, that's the third point. First you write the theory, then you write the algorithm, then you will write the diagram. And coming to the subtopics and the formulas, that I will not be discussing in this video. I will be discussing in a separate video. There are some sub points also. Anyways, this all I have covered in the theory video. There you can watch it. Okay. So that's all what is there about the k-means algorithm, and with a suitable example also I explained. Then we have agglomerative hierarchical clustering. First let's understand what is agglomerative and what is hierarchical. So by the name hierarchy, so there is a strength and weakness also. This is also same. See, for one only I am telling the strength and weakness. Rest all you have to write the same strength and weakness. Okay, what is the strength? It will be more efficient, less susceptible to the errors and all, and it will be less costly, like that. Some it is there, like the strengths are there, and the weakness are, it is not suitable for all types of data or the large data, or there is redundant data in it. Just write the strength sum and write the weakness sum. They will not read also. Okay, you will just have to write the strength and weakness. Most of them are similar only. Okay, most of the strength and weakness are similar. It is not much different. Even if they read, you will get at least more than 50% marks. Okay, so don't worry about strength and weakness. They are far more important topics that you have to focus more upon. Okay, so let's move on. Anyways, the more you try to keep in mind, the more chances of getting confusion, right? So keep as much less you can in mind, and there you have to expand in the exam. Okay, so let's move on to the explain of the agglomerative and the hierarchical clustering. So hierarchical clustering is a technique which is the second important category of clustering methods. So this is the first point. Hierarchical clustering is the method which is widely used, but it is means it is relatively old, but it is widely used. There what you will do, either you will merge or divide. Either you will merge or divide. If you know this much, your 50% task is done. Either you will merge or you will divide. Agglomerative is separate and hierarchical is separate. Okay, agglomerative is separate and hierarchical is separate. In agglomerative, what you will do, you will start with the points as individual clusters. Each step merge the closest pair of clusters. You will start with these many clusters. Here the clusters are there. As you can see, these can be merged together and these can be merged together. You will merge it. That's all what the agglomerative is. That is the merging. And the hierarchical means divisive. Hierarchy, as I told you, it is dividing into different means tree structures, right? So that is what the hierarchical is. Okay, so divisive means it is getting divided. When the name itself you can understand, divisive means getting divided. So that's what you have to say, that is the division. Okay, splitting. One is merging, one is splitting, and that's the first key point. First you have to write it is the old algorithm, but it is widely spreadly used, and two things are used there. In the agglomerative we will merge, and divisive you will split. That's the second key point. Third key point is you will be drawing this diagram here, because see in the question they have asked the diagram as well. Okay, see here. Types of clustering algorithm, that are two types, are agglomerative and divisive, with the dendrogram and nested cluster diagram. That's also compulsory. Fine. So you have to draw this diagram. This for the hierarchical, this for the agglomerative. Okay. So in hierarchical, what happens? It's getting divided into different parts here. Okay. And here what is happening, you are merging them into separate clusters. This is dendrogram, this is nested cluster diagram. This is the third key point. First key point, the definition. Second key point, the difference, two types, which is the agglomerative and divisive. Third point is the diagram and a slight theory regarding it. Again write the same thing what you wrote above. After drawing this diagram, that will help with the content. Okay. Then we have the algorithm. These are discussed in a separate video. Basically what happens, compute the proximity of a matrix, means how close the elements are with each other, that matrix will compute. And again means update the new things, merge the things or dismerge the things, split the things, do the processing, again do the repetition. See, all the algorithms do this only. First they will do something, then what will happen, they will do the processing, again they will repeat it, again they will do this, and again processing, again they will do, until no change is happening. they'll keep doing the process repeatedly until no change is happening. That's the main structure of all the algorithms present in data mining. Okay, see here, until the repeat until one cluster remains. Here the stopping condition is until one cluster remains. Only three things you need to keep in mind: what is the starting condition, then what is the process happening, what is the stopping condition. That's all. If you know this much structure, you can easily write the algorithm by your own itself, if you know slight theory also. Fine. So that was about the structure algorithm regarding the agglomerative and hierarchical clustering. Then we have the three things, which is min, max and average, very very important and repeated concept. What is min, max and average? Min, max and average are proximity measures. Proximity means closeness. Proximity means what? Closeness measure. Closest measure can be measured in three ways: min, max and group average. Min means what is the minimum distance between two clusters. If these are two clusters, what is the minimum distance? That's all. Just remember this diagram and write it in your own words. The minimum distance between two clusters is called min. What is the max? The maximum possible distance between two data points of two different clusters. What is the average? As the name suggests, find out all the distances, divide by how many distances you found. That's all. That's the group average. Very important question. Easily you can remember these T diagrams and score 6 to 7 marks, right? Then we have the mention the limitation of the algorithm. This already I discussed, I will not discuss again. Then we have the DBSCAN algorithm. Let's move on to this one. Same thing you follow here also. Know what is DBSCAN, the definition part. DBSCAN means density based scan. By the name itself, it's pretty clear. You will be clustering based on what? Density. You will be clustering based on density. Density is less, that will be one cluster. Density is medium, that will be one cluster. Density is high, that will be one cluster. Extremely high, another cluster. The clustering which is happening based on the density values is called density based algorithm. That's the first point you have to write, and you can make this diagram as well. Okay, that's the two key points finished. And here you will be using center based approach. These are the subtopics, because subtopics also have the marks like 1 or 2 marks. So make sure you mention this point, that it is center based approach. Center based approach means what? This is a circle you will make. You will choose a radius value and you will choose a center point. In the center point, how many points should be there inside this point? Based on that, the density will be decided. For example, if you have chosen a point A and you have chosen the radius as 10, in my radius 10 area, in this area, how many points I need to have so that I can call it dense? I mean, I can call it 100 points should be there, or 1000 points should be there, then only it will be dense for me, or it should be 1 lakh points, then only it will be dense for me. That depends on user to user. Fine. But the main key point is you will be choosing a center point, first key point. Second, the radius you will be choosing. Third key point what you need to mention is, in this radius and the area which is formed, in this how many points will be there such that I will call it as dense. Based on that, the clustering will happen. The low cluster might have 100, medium cluster might have 1000, highly extreme dense based cluster will have 1 lakh points. Okay, so based on this, the different clustering will happen based on densities. That is what the center based approach. Okay, if you go to the theory, the same things only you will get to know. Then we have the core point, border point and noise point, second subtopic. The first was center based approach. The second one is core point, border point and noise background point. See, the core point, border point, noise point is same as the min, max and average value. They have explicitly asked the question, what is core, border and noise points. So make sure you go through it very well. Okay, core point, border point and noise point. What are the key points you need to write here? That I will be explaining you. What do you understand by the term core? Before moving on to the theory, first answer my questions. What do you understand by the core? Core means important. Core means what? Important and the most crucial. So core means important one. Highlight like this. Border means what? It is not that important. It is outside regions. Noise means what? It is unwanted, useless stuff. Okay, unwanted, useless stuff, very very far from the important things, irrelevant concepts. Okay, like that you can keep in mind. So we have three categories here. What is core point is, that is the inner part of the density based algorithm. See, it is the interior point of the density based cluster. That's the core point. And the border point is, it is not the core point, but it is still falling within a neighbor of the core point. Means it is not that unimportant also, not that important also, the middle ones. Noise point is like out of syllabus concepts. It is neither the core point nor the border point. Okay, so you have to make what? The diagram. After I have written the definition of three things, see, you start from here. You will mention that there are three points classification for the center based approach. Three classifications are there: core point, border point and noise or background point. After you have mentioned these 2 points, that's the first key point. Then the second key point you have to write is the definition regarding this. What is core point? Important points. What is noise? Border points? It is not important, not unimportant also. And the third point is noise points, which is the border points or unwanted points. That's the next point. After that, finally you have to draw this diagram. Very simple. draw 3 circles like this which are overlapping like this, and make A in the first circle, B in between first and second circle, and C in the third circle. See, as you can see, this is the core point and this is overlapping the second key point, and third is outside A and B, both A and B it is outside. Write here noise, write here border, write here core points, and make some dots randomly here, that doesn't matter. Okay, make the dots randomly, don't worry about dot, it is here only, I should make here only, don't do like that. Okay, so that's what about the different points in the diagram. If you write this much, this will be sufficient for you. Okay, then we have what the algorithm for it and the limitation that I will discuss in a separate video. Then what are the second point I saw here? Okay, algorithm only. Okay, here also the same thing. Label the points. The first step is label the points as core, border, and noise. Eliminate the noise points. Make an edge between them. Assign the border point to the cluster and the core points. Then the thing will be over. What you are doing is you are collecting the syllabus from here. Okay. Then you are eliminating the concept which was not asked in the syllabus itself. You are just removing them from the study timetable, and then you are putting the edge between the core points that are within EPS and all. So what you are making is connection, like first what you will study, second what you will study, then make each group of connected core points. You are forming groups. This is the first topic, second topic, third topic I will study. After that you will assign each border point to one of the cluster and associated core points. You have a main 5 topics, suppose that you got to know from your syllabus. These are the 5 topics I have to cover, and there are few more concepts left here and here, few like not important much ones. So what you will do, I will study this one with this one. These are what border points. Remember, these are border points, these are core points. I will study this topic with this one, this topic with this one, this topic with this one. Like that you will assign, right? So finally, what you will do with the core points, you will assign the border values. That's all what is there in the DBSCAN algorithm. That is more than sufficient if you can write this much. Fine. Then we have the cluster evaluation methods. So in the cluster evaluation methods, the most common questions from this module in the previous paper. Cluster evaluation, don't miss at any cost. How many approaches are there? 3 approaches. Okay, how many approaches? 3 approaches are there for the cluster evaluation methods. So what do you understand by cluster evaluation? By the name itself you can understand, cluster evaluation means how well the cluster is, how better the cluster is, and how nice the cluster is, right? That's what the cluster evaluation, whether it is acceptable cluster or unacceptable cluster, that's what you are evaluating, right, or computing. That is the cluster evaluation. That's the first key point you have tried. Second key point, they are divided into how many types? 3 types: unsupervised, supervised, and relative. If you go through the notes, there is a lot of content regarding the unsupervised and supervised and relative, but the time is less, so I am just telling you what are the key points you need to write, and there you have to write in detail in your own words. Okay, easily you can write, just listen to me what I am telling. Unsupervised means what? Someone is not watching, like that only. Okay, no matter how stupid it looks like, remember like this only. You are doing some coding here, okay, and someone is watching you, your boss is watching you, that is called as supervised. If your boss is not there, not watching you, that is unsupervised. Relative means sometimes boss will come and watch, sometimes boss will not come and watch. Fine, sometimes boss will come, sometimes boss will not come. That is the relative, the mixture between the unsupervised and supervised. So third point you already got to know. Relative means just a small theory you need to write. It is a combination of unsupervised or supervised. So this is done relative. Just we are concerned with what you need to write in unsupervised, and I will be telling you what you need to write in supervised. In unsupervised, the first thing what you need to write is, it is a measure of goodness of the clustering structure. It is a measure of what? Goodness of the clustering structure, how well the structure is, by considering without considering the external info. Here the supervision is not there, so will not consider any external info. Without external info, you will try to find out if the cluster is good or not, measuring the what? Goodness of the clustering structure. Okay, so that's the first key point you got to know. What we are doing in unsupervised, measuring the goodness of the clustering structure without considering the external info is the second key point. Okay, after I have written this one, then the next what you have tried is, it's divided into 2 classes: a measure of the cluster cohesion and separation. Cohesion means attraction, separation means unattraction. Okay, separation means unattraction, far far, and cohesion means near near. Okay, that's what the cohesion and separation means. And cohesion means it is 1, very close. Separation means 0, it is very far. 1 and 0, this much only you remember. Okay, so and for cohesion and separation there are formulas. What is the proximity measures? The total sum is cohesion, and the proximity measures, the total sum is the separation. Okay, so here the formulas are same, but just the difference is how close it is that you are measuring here, and how far it is that you are measuring here. That's the second key point. You have to write about what is cohesion, what is separation along with the formula. So it measures the similarity and dissimilarity. Then what you can write is there are some validity functions like the Silhouette coefficient. Just remember the keywords here. Silhouette coefficient, just remember that Silhouette coefficient means there will be a value between -1 and 1, that is all. Do not remember anything, just remember Silhouette coefficient means there will be a value between -1 and 1. I will tell you how to expand it, do not worry about that. Just remember for now -1 to 1. Then measuring the cluster validation via correlation. What do you mean by correlation? If you have very best friend here, okay, this is you and this is your best friend and this is your another normal friend. The correlation between you and your best friend is high and the correlation between you and your normal friend is slightly low, right? That is the correlation. How close you both are, that is what correlation is. And measuring the cluster validity via correlation means in the cluster what are the data points are there, how closely they are related to each other, that measure is called as correlation. Okay, by that you are measuring if the cluster is good or not. So that's what I told you. If it is very close it is 1, if it is not close at all it will be 0. Very close means 1, not close means 0. So don't worry about these figures, I'll tell you what all you need to keep in mind. Then we have the supervised. The first one is unsupervised. I said some key points, have you noted down that? Then second one unsupervised. Here what you have to keep in mind is two things, classification and similarity. Two types of supervision. Supervision means here you will be considering the external factors. In the unsupervised there were no external factors, just by looking at it you are saying if it is close or not. Now comes the external factor. You can remember in this way, here is you, here is your friend. Okay, now suppose that there is an formula to measure based on a survey how close you are to your friend. By just looking you can say that if they both are together for a long amount of time, they will share the happiness and sadness together, they are close to each other, right? That is the unsupervised. Supervised means what? You will use some metrics or the formulas, means you will ask this person how much you are going to sacrifice for your friend, like that the questions you will ask and based on that you will collect some data. Same thing goes for here also, collect some data. Based on these two data you are judging whether they are best friends or not. Okay, whether based on the data you are judging best friends or not. If you are judging based on data, that is supervised. If you are not judging based on data, just by seeing, that is unsupervised. That's all. In supervised you will have some data. For the data you need what? Formulas. So formulas can be divided into two types, classification formula and similarity formula. Classification formula is very simple. Here you will have the entropy, purity, precision, recall, F measure and all. These are the different formulas. If you can remember you can go through it. So these are the key points you need to measure. Just the definitions are there. Different types to measure the closeness. Different formulas to measure what? The closeness. That is what is in the supervision. Okay. Similarity means you will have the methods like 1 is more close and 0 is not close. Okay. Based on that, ideal cluster similarity or ideal class similarity. Okay. Similarity has ideal class or cluster. Both will have 1 and 0, 1 and 0. That much only. Okay. That is in supervised. Coming to the relative method, it is a mixture of both, as I already told you. Like it is a, see here only it is written, a relative is the supervised or unsupervised evaluation measure that is used for the purpose of comparison. Both can be used, like boss is seeing you, boss is not seeing you, fine. An example you can give, the k-means clustering can be compared using SSE or entropy. Both can be used, SSE or entropy, both the measures can be used, relative and unrelative. That is what relative is. Now I will tell you how you need to expand. Okay, we will start from here for the unsupervised. See, cluster evaluation methods. First write the definition. What does that mean? By your own words you can write easily. What are the three types? Unsupervised, supervised and relative. Write short key points regarding what is unsupervised. Unsupervised means there will be no formula used, without using any formula. See here also they have written without considering any external info. What is external info? The formula itself, right? How you will get the external info? By applying some analysis and you will get the data. The analysis is nothing but formula only you are applying at the end of the day, right? That's what it is. Without using any formula, if you do, that is unsupervised. First key point. Supervised means by using formula you will do. Second key point. Relative means the mixture of both unsupervised and supervised. Third key point. After you have written this much, you have to expand each of these. What is unsupervised, what is supervised, what is relative. For the relative I told you, you will write the definition. After that give an example. K means can be done by two ways. K means can be done by two ways. The first one is SSE, second one is the other one which they are given. Okay. So in unsupervised you will write the key points. Firstly you will write it can be done in two ways, the cluster cohesion and the cluster separation. Cohesion is 1 and the separation is 0 in binary values. The more closer it is to 1 it is more cohesion, the more closer it is to 0 it is more separation. That is the first key point you need to write here. After that you will write the formulas. If you can remember, very simple, write this summation means symbol here. proximity, proximity, xy, xy. Proximity means closeness. What you are measuring here? Obviously you are measuring closeness only, right? Between what? X and y. So you will be writing proximity or closeness between x and y for all the data points. How you will denote all the data points? By the summation of proximity between all the points. That's all. For cohesion and separation, same formula. After you have written this much, then see that there are some factors. Okay, there is what? Some factors to measure it. What are the factors? Is a Sill-Hout coefficient. In Sill-Hout coefficient you will be having many data points, right, like this only. There will be many data points here, and each of these data points will be having some values, right? Each of these data points will be having some values. You will find out the average of these data points and then assign each of these data points to the closeness or the separation. This is the separation, this is the closeness. You will assign each of these data points to the separation or the cohesion, and instead of 0 it is actually -1 here. Okay, the range is -1 to 1. That's all what you have to write here. Okay, that is Sill-Hout coefficient. Or you can use by correlation. Correlation means how close they both are. For correlation you will use what? Confusion matrix. What is confusion matrix? This is confusion matrix. Here the data is present here like 1 2 3, for example 1 2 3. How close is 1 and 1? It is same, obviously it will be very close, same only, that's why it is 100%. 2 and 2 is also 100%, 3 and 3 is also 100%. How close is 1 and 2? How close is 1 and 3? That density is given here. 2 and 2 and 1, 2 and 3, 3 and 1, 3 and 2. How close these are? These values are given here. By these values you can understand how close they are. That is what the correlation is. That's the second one. And yeah, two only are there, right? Correlation and what was the first one? Sill-Hout coefficient. Fine, correlation and Sill-Hout coefficient. Before that you have to write the cohesion and the separation. Very simple. That's all what is there in unsupervised. In supervised, how many formulas you can remember? Better for you. First write it is classification and similarity. In classification you have these formulas, entropy and precision, purity and all. And in similarity you will have two things, cluster and classes. Two things, cluster and what? Classes. Okay. Relative means the combination of these both. Very easy, very important concept from exam point of view. Make sure you don't miss it. It's the most repeated one. Okay. Then what we have, the density based clustering algorithm. Three are there. Density based, already I told you what is the definition. The clustering happening based on the density is called density based clustering algorithm. Then you have three types, grid based, CLIQUE and DENCLUE. Here also I tell you what are the key points you are supposed to write in exam. Fine. So if they ask you regarding the just the basic definition regarding the density based clustering, write the definition of density based clustering, first key point. Second key point, there are three types, grid, CLIQUE and DENCLUE, and mention a few points regarding grid, CLIQUE and DENCLUE. What is the key point you will be mentioning in the exam regarding grid based? Is that you will have the data here. These data will be divided contiguously. These data will be divided what? Contiguously. Contiguously means continuously. See, the same thing I have written here also. Into a number of contiguous intervals. Each attribute will be divided into a number of contiguous intervals, creating a set of grid cells. Each of these cells is called what? Grid cell, grid cell, grid cell and all. When they will be created in the grid cells, then what you will do, you will assign the data values to each of these, in which cell it belongs, in which cell it belongs, in which cell it belongs, based on what? The density. That's all what is grid based. That much only you have to remember and expand in your own words. The strength and weakness is there, you can write in your own words. CLIQUE. CLIQUE means what? It is a grid based, but it is method for finding subspace clusters. Subspace clusters, remember in this way. There is a space here, okay, there is a space here, divided into different parts, each will be what? Subspace, and by using your hand make this in the shape of a cluster. How does cluster normally look like? Circle. So what does this algorithm do, which is CLIQUE? It will take a space, it will divide into different parts, each is called subspace. It will make the subspace into cluster, right? It looks like very stupid, but this will help you remember the formula, the definition. Fine. It will divide the space into different subspace clusters. That's all what is the CLIQUE. It is the same grid based algorithm, but instead of forming grids, it will take the subspace, make a it will take the space, make the subspace and form it into a cluster. Algorithm is also same. I will discuss this in depth in the separate video. Then strength and weakness. Then the last one is DENCLUE. DENCLUE, don't read the theory, just remember what I tell. Remember this diagram. Take your pen, make a graph like this and draw a line like this. Okay, randomly draw a line like this. Okay, then what we have, sometimes you will get a peak here and the dip here. This is a peak, dip, peak, dip, peak, dip. So what will happen is you will get some peaks here and you will get some dips here. So what you will do, first peak what you got, that you will record and write in the register. I jumped this much high, like that you will write. What is the distance here? The 10 meter. I jumped 10 meter high. Then again you will go down and jump. I jumped 20 meter high. Then again you will jump. I jumped only 1 meter. Then 30 meter. Like that you will keep on writing. Iteratively you are finding the most peak value. Most peak value means what? Most dense value. Here in this case it is not jumping, here it is the dense value. So the more dense value you have jumped, the more the similarity will be there in between the 2 points. Like, see, the more dense something is, the more similar those things are, and that will form one cluster. So in this way you are trying to find out the clusters. That is the DENCLUE, density clustering. Based on the density you are clustering. Okay, so here also the same thing. The resulting overall density function will have local peaks. These local peaks can be used to define clusters in a natural way. Okay, write this definition, make this diagram, explain whatever I told in your own words. If you go to the algorithm also, if you go to the theory also, the same thing you will find whatever I told you. Okay, and then you have the limitations and the advantages that you can write in your own words. Okay. So the next one is regarding the graph based clustering. So as I told you, graph based clustering, sir has told that it's not much repeated, so I will not cover in this topic. So this one was covered in the theory, you can watch there in the theory part video I have explained. Last one is a scalable clustering algorithm. This is a very good topic. Here you will have two things, CLIQUE and BIRCH. The definition between CLIQUE and BIRCH, the diagram and the theory. These three things if you write, it will be sufficient for you. So let me tell you what you have to write in the three things. Okay, so let's move on. The scalable algorithm. Firstly, what do you understand by the term scalable algorithm? That you answer me first, then we will move on to the next part of the video. Scalable clustering algorithm mean what? What is scalable? Scalable means large scale. This is a small scale, this is large scale. An algorithm which can be used for large scale is called scalable clustering algorithm. An algorithm which can be used for large scale of clusters is called what? Scalable clustering algorithm. Fine, that's the first key point. What is scalable clustering algorithm? Second key point, why do we need scalable clustering algorithm? The thing why you need scalable clustering algorithm is because of these things. Very large data cannot be handled easily. Very large data cannot be stored easily, cannot be processed in a smaller time. It cannot be handled in a separate time, smaller time. It is very insecure to handle this much big data, and it is means it can be leaked, or it can be redundant data, or it can be harmed. Many things are there. Large scale is very crucial and a complex topic, right? So that's why we need to have some algorithms by using which we can handle the large data. Handle what? The large data. What are those algorithms? The scalable clustering algorithm. Here we will be learning some algorithms by using which we can do what? Handle large data very easily. I can give you an example. Suppose that you have the data points here, like in the form of numbers. Some numeric values are given in a register. Suppose that you have a register, in that some numeric values are given. By seeing the numeric values, there are like 1 lakh numeric values. Can you make anything out of it, like what it is talking about, how are the trends present in that? Nothing you can make about. But how to handle this is, if you write these same points in the computer and make a graph of it, and if the graph looks like this, what you can observe? There is an exponential growth. Within 1 second you can tell it is exponential growth. How you can how could you do it? This is large data, right? How could you do large data in 1 second? Because you change the technique. Change what? The technique. When you change the technique, the things will change. When you change the technique, the things will change. Things will become easier. So it will be easier to know what is happening at the large scale. That's what we are doing here also. There are some clustering algorithms, but for large scale it is not possible, just as this one. So we'll be learning two algorithms by using which we can transform the existing clustering algorithm to the new clustering algorithm, so that large data can be visualized very easily. That's all what we are learning. Two things we'll be learning, CLIQUE and BIRCH. So before that you need to know the second key point. What are the general strategies? Reduce the number of proximity calculation. Proximity means closeness. If there are large number of data points, for all, if you try to calculate what is a distance between this two, this two, this two, this two, then for this point all, for this point with all, it will take a lot of time. That's why that's the first key point why large scale algorithms is hard and time processing. We are calculating proximity for all. If it is small data points, you can easily calculate, but if for large data points, proximity becomes a very big issue. Okay, that's the first point. Sampling the data. If you sample the data into sub points, whatever we apply here, that will be applicable for all of this. Just once we have to do, it will be applicable for all. Very easy, right? Then we have partitioning the data, same as sampling. Clustering the summarized representatives. Okay, so there will be a clusters here. For each cluster, what summary you got from here, that will be similar to the summary which is getting applied here, right? If you make a group of 10 students and say that they are learning like 7 to 8 out of 10, here also it will be that much only, here also this will be that much only. If you take the whole university, right, the cluster, what answer you get, that will be applicable similar to this one or this one. it will be slightly more, slightly less, but average it will be that much only, right? That is what clustering summary representations. Okay, so two good examples of scalable clustering algorithm are CURE and BIRCH. I'll tell you what are the key points you need to write in CURE and what are the key points you need to write in BIRCH. Okay, so what are the general issues? First, let's discuss the approaches of scalability. So see here only I told you, don't go through all the notes, time is less. What I'll tell you, just remember that for many objects you cannot do. That's the first issue. Second thing is multi-dimensional spatial access method. Multi-dimensional, many factors will be there. It's hard to access. Proximities, bound on proximities means you cannot calculate the distance between all the data points in between. That's the third one. Sampling means if you form it into small groups, it will be very easy to do. And partitioning means the same as the sampling, write the same theory. Summarization means you will summarize one thing, it will be applicable to all the things. Parallel or distributed computation, you will have the distributed computation means in the same time you will be processing many things at the same time. That is what the parallel and distributed computation. If you have a task to write 100 papers, what you will do, you will give 10 papers to your friend, another 20 papers to another friend, and all your friends will do your homework, right? So that's what the parallel computation is. In the data mining also, that same thing is happening. The whole task is divided into different parts here, and all things will happen parallelly. So it will happen very fast. Okay. Then we have okay, let's discuss about the BIRCH and the CURE. Okay, so what is BIRCH? BIRCH means balanced iterative reduced clustering using hierarchy. So this is the first key point. You need to write the full form of BIRCH. Second key point is what is happening in BIRCH. It is an iterative method which uses reducing and clustering. First you will cluster and you will see which is the redundant value, you will reduce. Again you will cluster, again see what is the redundant value, you will reduce. In which way it is happening? Hierarchical way. That's all. Iterative reducing and clustering using hierarchical method. And what it is balanced. Here you can get 3 to 4 points. For each point if you explain, you can easily fill the content. 3 to 4 points easily you can get here. Fine. And next key point you need to write is this formula. Each node can be represented by the data points n, ls and ss. N, ls and ss are the triple of numbers. N is the point, L is the linear sum of points, S is the sum squared of points, squared sum of points. These 3 points you have to write. Okay. After that, just go to the algorithm. Here you will load the data, you will form a tree, you will make it as balanced, again redistribute, and means repeat the same process again. That's all what is in BIRCH. CURE, clustering using representatives. Clustering using what? Representatives. First start with the diagram for this one. See, for learning different algorithms there are different approaches. You cannot learn all the algorithms in the same approach because some will be easy in some approach, others will be easy in different approach. For this algorithm, remember this diagram first. Okay, in this diagram there are many salaries, a large scale. Okay, this very large scale, like total full India. Okay, here the different ages and the different salaries are given. Now you want to form clusters. What you will do, you will randomly take some points here. Okay, like this, you will take randomly the points, and then what you will do, you will find what is closer to this point, you will form one cluster, closer to this point, closer to this point, closer to this point. After you have done that, some will be again left. Again you will take some random points and form the clusters. Again you will take some random points, form the clusters, until you will do, until no changes happening. No matter what random means value you take, still the cluster will remain same. I can show you an example. I can show you an example here. What's actually happening is, here if you have one cluster here, okay, let's take some key points. Okay, see, this one key point, this one key point, randomly I am taking. Fine, I am taking randomly only, right? So after I have taken this one, I will take this as first cluster, second cluster, third cluster, fourth cluster, fifth cluster. Okay, then if I take this one, closest to this one is this one, this one and this one. If I take this one is closest to this one, this one, this one. No matter what random point I take in this one, it will not go to the other one. It will be close to this one only. That is what CURE. You will see the whole large scale. You will see what is common. You will take one big cluster, here one big cluster, and all those form a cluster. That is called as CURE. CURE means clustering using representatives. Representative means what? The random points you want to took, that is the representatives. You are clustering based on what? Representative values. That's all. CURE and BIRCH, that one only you have to write. Algorithm I will discuss in a separate video, and the numericals regarding it. So that's all for the module 5, and make sure you hit the like button, subscribe to my channel. Your support helps me make more videos like this, and thank you so much for watching. I will see you in the next one.